Hi everyone, in this tutorial I'll show how to heat a system in Amber. In the last video we learned the minimization process, and this is the tutorial that we are following. This is the decamer system that we chose. Now this is the topology file that we created using Xlib, and this is the coordinate file that was generated after the second stage of minimization, and this is the input file for heating that will run to perform the heating process. But before that we'll learn the meanings of these flags. We want to increase the temperature of our system from 0 Kelvin to 300 Kelvin. So here in the input file, temp I denotes to the initial temperature of the system, and temp 0 is the final temperature. We have set temp I to 0 and temp 0 to 300. Now NSTLM is the number of MD steps to be performed, and dt is the time step in picosecond. Multiplication of the number of MD steps by the time step give the total simulation time. Now we want to perform the heating process for 100 picosecond, and we have chosen 0.002 picosecond time step. So we have to set the number of MD steps to 50,000. And these are the other flags. You can go through the Amber manual for more details. We'll heat the system at constant volume, so we'll set NTP equals to 1. Now we'll use Langevin thermostat to control the temperature, and utilize the shake algorithm to constrain the bonds involving hydrogen atoms, and we'll specify the non-bonded cutoff distance to 10 angstrom. To apply resistance force on the DNA molecule, we have to set NTR equals to 1, and we'll apply 10 kilocalorie per mole resistance force on the DNA molecule, that is residue 1 to 20. This is the general command to run the heating process. So we'll use pmemd module of Amber to run the process, and this is the input file that I showed earlier, and this will be the output file that will be created after the heating process. This one is the initial topology file that was created using Xlib, and this is the input coordinate file that was generated after the previous process, that is the second stage of minimization, and this will be the output coordinate file that will be created after the heating process. Now as we have applied resistance force on the DNA molecule, we have to provide reference coordinate file generated from the previous process, that is the second stage of minimization. So this is the file. We have all these files in this folder. Now open the command line and go to the folder, then just run the command. The heating process have been completed, and these files have been generated. So this is the output file, and this is the output coordinate file. Now if you open this file, you can see that 100 picosecond of heating has been completed, and the temperature has reached around 300 Kelvin. So I hope this tutorial will be helpful for you, and thank you for watching.